Hello everybody and welcome to today's lesson on volume. Today our objective is we will be able to use formulas for volume of three-dimensional objects to solve real-world problems. Now let's remember what volume is. Volume is the space contained in the interior of a solid. I want you to think of filling something up, container or contained in something. Air, for example, is an example. For example, air, for example, air or a liquid, and something that's held in a container. Container holds something like an air or liquid. The units we're using for volume are cubic units. So, for example, cubic meters, cubic centimeters, or cubic inches. Or cubic inches. Let's dive right into some examples. A rectangular pyramid that is 7 meters tall has a base that measures 5 feet by 3 feet. How many cubic feet are contained inside of this pyramid? And here you already have the keywords ready. And here you already have some keywords that will indicate to you what we're talking about. Cubic feet and contained indicates that we're talking about volume. So let's look for the formula of the volume of a pyramid on your formula sheet. Always use your formula sheet for that. And let me write down the formula here on the left. The volume is equal to 1/3 the base times the height. And remember the capital base, and remember base with a capital B, that is the area of the base, as opposed to base with a lowercase b, which is just the side of a rectangle, a triangle, or a parallelogram. Capital B, that's the area of the base, so that is what we have to find first. And we have been told that we are dealing with a rectangular pyramid, so our base is a rectangle. And let's go back to the text and look at. So our base is a rectangle. And let's go back to our problem to look at the information we have about that base. It measures 5 feet by 3 feet. So 5 feet is the length and 3 feet is the width. And for the area of a rectangle, we're using the formula that is also on your formula sheet, which is the area is 2 times the length plus 2 times the area is equal to the length times the width. That is 5 times 3, 15. And 15 is an area. And so right now we are already dealing with square feet. Let's see where we get though. So this area we're going to use in our formula for volume for the area of the base. So now we have 1/3 times 15. So we have 1/3 times 15 times the height of our pyramid, and that was given to us as 7 meters times 7. 1/3 times 15 times 7 is 1/3 times 15 is 5 times 7 is 35. And since we took the area of 15, which was already in square feet, multiplying it by and since we're talking about volume, we need to use a cubic unit. And since we're talking about volume, we need to use the cubic unit, and that is cubic feet. 35 cubic feet is the volume of our pyramid. On to our next example. Construction workers drill a hole into a concrete cylinder. Determine how many cubic feet of concrete remain. So this is a problem where in this problem we have to find the volume of a cylinder, but we have a hole in there and we have something remaining, so that means we need to subtract stuff. We're going to use the formula for the volume of a cylinder, which is V is equal to pi r squared times h, and that will give us the volume of a cylinder. Now we have two cylinders, if you think about it. We have a bigger cylinder that's filled with concrete, but then something got taken away, and now we also have a smaller cylinder filled with air. So we have to find but then a hole was drilled into it, and that created a smaller cylinder, and that smaller cylinder you can think of is filled with air. So the big cylinder filled with concrete needs to be, so we need to find the volume of the smaller cylinder, and then so we need to find the volume of the bigger cylinder of concrete, but then take the volume of the smaller cylinder of air and subtract that from the bigger volume. And then we will see what is left on the outer rim here filled with concrete. So let's find the volume of the big cylinder first. That is the outer one. The volume is equal to pi times r squared. What is the radius of the bigger one? We're told that the diameter is 10. That means the diameter is 2 times the radius. The radius is 10 divided by 2. That means 5. 5 squared times the height. And the height is 15 feet. When we have problems like that where our result will be used again in some more calculations, it's easiest not to go and take the decimal right away, but leave our pi in the answer. So we're just going to calculate the number part. 5 squared times 15, 25 times 15 is 375 times pi. That's the volume of our That's the volume of our outer cylinder that's filled with concrete. Now let's find the volume of the smaller cylinder that's filled with air. The volume of that one is pi times. Now what's the radius of the smaller one? We are told that the rim is 1 feet wide. That's on the right just as much as on the left. So the diameter of the smaller one is 10 minus 2, which is 8. That means the radius is equal to 4. So pi times 4 squared times 15. The height is unchanged, still the same thing. And again, we're going to keep pi. 4 squared 16 times 15 is 240 pi.